Assalamualaikum and good afternoon. Today, I will present about the HVAC system in hospital. But before that, I will introduce our group members first. Muhammad Umarul Ad-Din bin Jasmi, myself, Muhammad Izzat bin Saleh, Muhammad Shazwan Zulhilmi bin Muhammad Qasim, and the last one is Muhammad Adib bin Muhammad Nur Adnan. Let's continue for the introduction of the HVAC system. HVAC stands for heating, ventilation, and air conditioning. The main purpose of the HVAC system is to provide thermal comfort and acceptable indoor air quality for certain types of required spaces. HVAC system controls the ambient temperature, humidity, airflow, and air filtering. Then, a chilled water system uses water instead of air to cool the required spaces. The chilled water system is commonly used in a medium to large scale building. Let's continue for the next part for this presentation, which is HVAC type selection. For hospital, the common type of HVAC system that been used is a water-cooled chiller HVAC system. There are a few reasons why this HVAC system is suitable for hospital. The first one is it is suitable for hospital because it is medium to large size building. Next, the water-cooled chiller HVAC system usually has better energy efficiency. This will reduce the electric consumption. The water-cooled chiller HVAC system also has centralized storage for refrigerants. Why this is considered as an advantage is because when the technician doing the maintenance, it is much easier for them to maintain the HVAC system because all of the refrigerants is at one place. The next one is water chiller is more flexible because it has many different configurations depends on the building itself. This explains how flexible the water-cooled chiller HVAC system is. The system is easier to configure to a different system because we're able to select a certain type of configuration for a certain type of building, which also may reduce the overall cost of the system. But then there is disadvantages for this water-cooled chiller HVAC system. The disadvantages is the system is complicated to install, which lead to higher labor costs. That's all from me. Let's continue for the next part of the presentation.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Umarul from 3B Bmmh Group 2, matric number B0919103363. So now I will present about the air system ducting for hospital building. So why are we choosing ducting system as the air system? Ducting is necessary for carrying heating and cooling air from HVAC equipment to point throughout building. Without this pathway, the conditioned air would have nowhere to go and would not be able to reach the building that need to be warmer or cooler. So from this picture, this is our example of the ducting system. So next, how the ducting operation. The air duct are collection of tubes from the air distribution network of HVAC system because the rational ducting are mostly considered for ducting work operation. The air supply will supply air from the supply to all room, and then the heat air will be returned. So this supply will be connect to all room and also the return. So next, the benefit of duct system. First is cost saving. The reduced cost of energy in building, air conditioner reach your living space, and heating and cooling equipment run at optimal performance. Second, increase comfort. Experience even temperature throughout building and increase airflow. Third, improve health. Those who suffer from the allergic or asthma will benefit from the increased air quality. And the last one is the prolonged lifespan of HVAC equipment. It means clean, well-maintained duct, circulate air clean through your building, preventing indoor wear and tear on system component due to dust or another particular. So next, the type of duct. So for our type duct is we use a fiberglass duct. For the some sheet of duct metal are lineared with a fiberglass on either inside or outside. So this is how the material we use for our ducting. This unit provides insulation to keep air in the correct temperature to prevent the formation of condensation and muffle the sound of HVAC system. The ability of muffled sound make fiberglass lead duct a popular choice in office or commercial building. So for the benefit of the fiberglass is corrosion resistant. Under duct fiber reinforced duct is specially designed with withstand the harsh underground environment. Our FRP duct stand up to water temperature, charge, and acid soil condition. Second is a fire resistant. All surface of under duct and fitting as a finished composite meet the flame and smoke requirement of a class 1 duct per UL 181 and UMC 1 to 10. So next is the high strength yet lightweight. The Flamen Wow FRP composite has a higher strength to weight ratio than steel, being the structural material large, lightweight fiberglass duct section can be shock fabricated and shipped to the job street for easy installation. So next we go to the layout hospital. We have redesigned using our AutoCAD the airflow for ducting and diffuser. So the green one is for ducting and the yellow one is for the diffuser. Every room has been calculated how the size of ducting and how many ducting have used and how many diffuser we have used. So that's all from me. So I will hand this presentation to my friend. Thank you.
Assalamualaikum. My name is Muhammad Adib bin Muhammad Nur Adnan. So I'm going to share about the component selection that we use in this building, which is chiller system. So this building are using water-cooled chiller system, and water-cooled chiller system unit is a type of chiller system which consists of four main components such as compressor, condenser, expansion valve, and the evaporator. And chillers can be found in most medium to large building and will produce the chill water that is used to provide air conditioning. There are many different types of chiller, but essentially they all have the same main components. This one is compressor, and the compressor is the prime mover. It creates a pressure difference to move the refrigerant around the system, and there are various design nowadays of a compressor, which is But the most common is the four of the images here, which is we have centrifugal compressor, scroll compressor, and reciprocating compressor. And the compressor, it is always located between the evaporator and the condenser. Secondly, we have condenser, and the condenser is always located after the compressor and before the expansion valve. And the purpose of the condenser is to remove heat from the refrigerant which was picked up in the evaporator. There are two main types of condenser, which is we have air-cooled condenser, and what the building use is the water-cooled condenser, which in this picture. So for this building, they are using water-cooled condenser, which will repetitively cycle condenser water between the cooling tower and the condenser. The hot refrigerant which enters the condenser from the compressor will transfer its heat into this water, which is transported up to the cooling tower and rejected from the building. The refrigerant and the water do not mix. They are kept separated by pipe wall, the water flow inside the pipe, and the refrigerant on the outside. The next one, we have expansion valve. So the expansion valve is located after the condenser, between the condenser and the evaporator. The purpose is to expand the refrigerant and reducing its pressure, and it increase its volume, which will allow it to pick up the unwanted heat in the evaporator. And lastly, we have evaporator, and the evaporator is located between the expansion valve and the compressor. The purpose of the evaporator is to collect the unwanted heat from the building and move this into the refrigerant so that it can be sent to the cooling tower and rejected. The water cools as the heat are extracted by the refrigerant. The chill water is then pumped around the building to provide air conditioning. The chill water then returns to the evaporator, bringing with it any unwanted heat from the building. So that's all from me. Thank you.
Assalamualaikum and good morning. I bid to Dr. Zulkarnain, our lecturer, and my name is Muhammad Shazwan Zulhilmi bin Muhammad Qasim, and I'm from 3 Bmmh. So today I would like to present about the efficiency calculation. Okay, since we do not get the data on hand due to our current conditions, we just managed to fill in the formula that is needed to calculate the efficiency. Okay, the first one is about the electric efficiency, where the output energy is divided by the total power input times by 100%. The second one is about the COP, or coefficient of performance, where we calculate the cooling performance of the HVAC system. So this is the formula where COP equals to Q cool over total net power. Okay, the next one, we go with energy efficiency ratio, or EER, where EER is used to rate an air conditioner, which we calculated as the output cooling energy in BTU divided with the input electrical energy. Okay, the SEER, or seasonal energy efficiency ratio, is to get the ratio for the cooling output of an air conditioner, where the formula is quite similar with the EER. Okay, now I would like to present about the conclusion. In a nutshell, health and energy efficiency plays a huge role in the production of any HVAC system before being released to be used by the consumers. By doing this assignment, students manage to understand these concepts are very important, which can affect our daily life. Okay, based on our selection of HVAC system, which are the water-cooled chiller, the student managed to have a better understanding of the basic principle which is being used. And for this case study is the hospital, which they rely heavily on air conditioning in their buildings. Okay. The efficiency is needed to be calculated and able to assume the level of performance of the system. Neglecting the maintenance check can result in damaging the system and wastage of resources and money. Okay. Aside from that, it enables consumers to be wise in their usage and ensure providing a better quality air to their patients. Hence, all objectives have been achieved and completed. Okay. So now I would like to thank Dr. Zulkarnain for lending his ear to hear our presentation. And I wish him a good health and always stay safe. Thank you.